Hello everyone and welcome back. Till the last session, we have seen the different number representations like binary and hexadecimal. We also have learned how to perform the basic arithmetic operations like additions, subtractions in them. In order to concretize those concepts, in this session, let's solve some problems of number representations. So without any further ado, let's get to learning. Coming to the topics that we are going to cover in this session, today, we will solve 7 problems on different number systems. So let's begin. Consider the first question. Perform the binary addition between 1101 and 1011. So let's solve it. Now if you remember, when we learnt about the addition in binary, we actually formed the truth table, right? Now in this truth table, can you notice which is the most important part? It is when we add both 1 and 1 together. It gives us the value 1, 0. Basically, we get the sum as 0 and the carry happens to be 1 in that case. Now what about the other cases? Well, in these, we only get the sums. So all we need to remember is this part. Now let me tell you, if we understand the configuration of the binary numbers, we don't really have to remember this. Let's consider the binary numbers one after the another. 0, 1, 1, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and so on. Now 0 is also 0 in decimal. 1 is also 1 in decimal. Now what about 1, 0? This is 2 in decimal. Coming to 1, 1, this is 3. 1, 0, 0 is 4 in decimal. So essentially, this is 5. Then 1, 1, 0 will be 6. And so on. Now if you notice this, to 0 if we add 1, we will get 1. Now to 1 if we add 1, we are supposed to get 2, which is 1, 0 in case of binary. Then again, with 1, 0, if we add 1, we will get 3, that is 1, 1, and the process will continue. And it's same for all the different number systems. That's how naturally the number systems work. For an example, if we consider decimal, what comes after 13? Well, if we add 1 with 13, we will get 14. Adding 1 to 14, we will get 15, and so on. Following that, with 1, when we are adding 1, we are getting 1, 0, that is the next number after 1 in binary. And that's we are having in this particular case. With 1, we are adding 1, and we are getting 1, 0. So it's all about remembering how the numbers are being formed in case of binary. And how to form that? We already have studied about it when we learnt about the binary number system, didn't we? Let's now proceed further with the addition. We have got the origin as 1101 and the addend is 1011. Let's perform the addition now. 1 plus 1 is going to give us 1, 0, so we will have the sum as 0 and the carry is going to be 1. 1 plus 0 will be 1 only, and then again 1 plus 1 will give us the sum as 0 and the carry is going to be 1 again. 1 plus 1 will give us 1, 0 and 1, 0 plus 0 will give us the sum as 0 and the carry is going to be 1 more time. Now notice, with 1 we are adding 1, so we are going to get the number 1, 0. Now with 1, 0, if we add 1, we will get the next number in line. Now what comes after 1, 0 in case of binary? It is 1, 1. Let's now check whether our addition is correct or not. For this, we will take help from the place values. Consider the origin. It is 8 plus 4, that is 12, plus 1, that is 13. Now what about the addend? 8 plus 2, that is 10, plus 1, that is 11. Now let's consider the sum. We have got 16 plus 8, that is 24. And it's correct. Because 13 plus 11 is always 24, isn't it? Let's move on to the next question. Subtract the binary numbers 10101 minus 1101. So let's try to solve it. Now I hope you remember the session subtraction in binary number system. There also we formed a truth table, didn't we? Now I hope you remember this truth table. Let me quickly go through this. 0 minus 0 will definitely give us the difference as 0 and we need not borrow anything. Then we have 0 minus 1. Now we are going to talk about it a bit later. Now we have 1 minus 0. The difference is going to be 1 and we need not borrow anything. And in case of 1 minus 1, the difference is going to be 0 and we also need not borrow anything. Let's now get back to this. We are essentially talking about 0 minus 1. That is, the minuend bit is lesser than the subtrahend bit. In this case, we need to borrow. And what we can borrow? It is 1. Now notice, from 1, 0, since we have borrowed the 1, and now the minuend is a 2-bit number. Now from 1, 0, if we subtract 1, what will be the answer? I hope you remember that 1 plus 1 is 1, 0. So 1, 0 minus 1 will be 1. And that's why the difference is 1. And for this particular subtraction, we need to borrow 1. So this is the most important part of this truth table which we have to remember. Let's now proceed with the subtraction. We have got the minuend as 10101 and the subtrahend is 1101. Let's perform the subtraction. 1 minus 1 will give us the difference 0. 0 minus 0 will also give us the difference 0. Then again 1 minus 1 will again give us the difference as 0. Now what about this case? The minuend bit is 0 and the subtrahend bit is 1. Now we can go with the traditional approach, that is the borrowing and all. However, if you remember, I had shown you my preferred way and I believe that's way easier. I hope you remember what I taught you in that session. Well, from the bit where the minuend bit is less than the subtrahend bit, we will keep on moving towards the left, that is towards the most significant bit, until we encounter 1. And once we encounter the bit 1, we will consider all the bits till then. So, instead of a unit, now we will consider this entire block. Notice, from 1, 0, we are subtracting 1. And we all know, from 1, 0, if we subtract 1, we will get the difference as 1. Let's now check whether our subtraction is correct or not. For this, we will again need the place values. Now coming to the minuend, 16 plus 4, that is 20, plus 1 will give us 21. What about the subtrahend? 8 plus 4, that is 12, plus 1 will give us 13. Now let's talk about the difference. Well, 8 only, isn't it? Now notice, from 21, if we subtract 13, we are supposed to get 8, isn't it? Now this is how we can perform the subtraction. However, if you don't want to take the burden of borrowing or even want to follow this process which I explained, we can always solve this by performing addition instead of subtraction. I hope you remember the ones and the twos complement techniques. Now 2's complement technique is easier because it involves lesser number of calculations. So how about we solve this question regarding that? So our minuend is going to be 10101. Now coming to the subtrahend, it is 1101. Now before we proceed further, I have to mention something in this regard. Either we are performing subtraction using 1's complement technique or 2's complement technique, we need to make sure that the number of bits in minuend and in subtrahend are same. Now notice in this case, the minuend is of 5 bits, whereas the subtrahend is of 4 bits. Therefore, we will place a 0 in the most significant bits place of the subtrahend. Now notice, both of them are of 5 bits. Now we can proceed. So, our minuend, which is essentially the addend in this case, is 10101. Now what about the addend? Well, for that, we will need the negative inverse of the subtrahend. And I told you earlier, we will get it using 2's complement. Now I hope you remember how to find out the 2's complement of a number. Basically, we will traverse the number from the least significant bit towards the most significant bit, and we will keep on retaining the bits until we encounter 1. Once we encounter the first bit as 1, we will retain that as well. However, the rest of the bits will be toggled. So 0 is going to be 1 now. What will happen to 1? It will be 0. 1 is going to be 0 and 0 is going to be 1. Now we can perform the addition. So 1 plus 1 will give us the sum as 0 and the carry will be 1. 1 plus 0 plus 1, that is 1, 0 again, will give us the sum as 0 and the carry will again be 1. 1 plus 1 will be 1 0, and 1 0 plus 0 will give us again 1 0. So the sum is 0 and the carry is 1 once again. Now 1 plus 0 is 1, and again 1 plus 0 will give us the sum as 1. Finally, we have got 1 plus 1. So what will be the sum? It is 1 0. Now notice, the subtraction of two 5-bit numbers can never be a 6-bit number, so we are going to discard the carry. Now did we get the correct answer? Well, we have. We were looking for 1000, which we have got in here as well. Let's now focus on the next question. We are supposed to add the hexadecimal numbers 2F and A8. So let's try to solve it. So our origin is 2F and our addend is A8. Now I hope you remember the addition in hexadecimal session. There I told you about some shortcuts, didn't I? One of the shortcuts were, with F, there is the largest one-digit number of hexadecimal. If we add any other digit, in the sum we are going to retain the digit which is 1 less than the addend. And that's also the case for decimal as well. Now notice, with F, we are adding 8. So, in the sum we will have 7. However, we will definitely have a carry. Now with 1 we will add 2, that is 3. Now with 3 we are going to add A, which in decimal is 10. So we will get the answer as 13, which is D in case of hexadecimal. So the sum of the most significant digits is going to be D. So the result of the addition 2F plus A8 is D7. Let's now move on to the next question. Subtract the hexadecimal numbers B4 minus 6D. Let's try to solve it. So our minuend is B4 and we have got the subtrahend 6D. Now since we are performing subtraction, it's always a good idea to have our reference chart. Also, in case of subtraction, we generally borrow. And since we are talking about hexadecimal numbers, we will borrow 1 0, which is 16 in case of decimal. So preferably, we should also include this in our chart. Let's now perform the subtraction. Notice the least significant digits. The minuend digit is 4 and the subtrahend digit is D. And D of hexadecimal is actually 13 in decimal. So clearly, from 4, we cannot subtract 13. Therefore, we need to borrow. Now, if we borrow 1 from B, we will be left with A. Now it is 1 4. Remember, it is not 14. Now, if it is 1 4, that means with 16, that is 1 0 of hexadecimal, we will add 4. And that will give us the value 20. Now, from 20, if we subtract D, that is 13 of decimal, we will be left with 7. Let's now focus on the next unit. From A, that is 10, we are subtracting 6. So we will get the result 4. Therefore, the difference between B4 and 6D is 4 7. Let's now focus on the fifth question. We are supposed to add the binary numbers 101 101 and 110010 and then convert the result to hexadecimal. So let's solve it. Our origin is 101101 and the addend is 110010. Let's perform the addition. 1 plus 0 will give us the sum as 1. 0 plus 1 will also give us the sum as 1. Then again 1 plus 0 will give us the sum as 1. 1 plus 0 once again, so 1. Coming to the next unit, 0 plus 1 will give us 1. Finally, 1 plus 1 will give us the value 10. Now this is the result of the addition. Now we are supposed to convert the result to hexadecimal. Now we already know how to convert any binary number into its equivalent hexadecimal number. For this, we will start grouping the numbers from the least significant bit towards the most significant bit. Now if we consider the least significant 4 bits, this is a group. Now notice we have only got 3 more bits. So in order to form a group of 4, we will consider another bit that is 0. And now we can have a group of 4 bits. Focus on the least significant group. 1111, essentially 15 in case of decimal. Because if you consider the place values, it has got the place value 1. With 1 we are adding the place value 2, so 3. Now with 3 we are adding the place value 4, that is 7. Now with 7 if we add the place value of 8, it will give us 15, which in case of hexadecimal is F. Now what about the next group? The place value of this is 1 and the place value of this is 4. So 4 plus 1 will give us 5. So this is the converted hexadecimal value of this binary result, that is 5F. Let's now move on to the next question. Add the hexadecimal numbers 1A, 3 and 2E, then convert the result to binary. So let's try to solve it. So we have the hexadecimal origin as 1A, 3 and the addend is 2E. Now notice, with 3 we are trying to add E, that is 14 in case of decimal. So clearly it will be a 2-digit output. Now we already know when we add two hexadecimal 1-digit numbers, if the outcome is a 2-digit number, then the carry is always going to be 1. All we have to figure out is what will be the sum. And for that, we already have a formula. And what was that? So with 16, we are going to add x. That is, we know that we will have a carry and the carry is going to be 1. So the place value of that is 16. Now with that, we are going to add x, that is the value which we are yet to figure out. Now in order to find out x, we also need to know the binary equivalent of this. Now with 3, if we add e, that is 14, we will have 17 as the result. Now the equation is complete. Now from both the sides, if we subtract 16, the value of x we will get as 1. So we will have the sum as 1 and the carry is going to be 1. Now notice, 1 plus a, that is 10, plus 2 will give us 13, and 13 in case of hexadecimal is D. Now what about the most significant digit of the origin? Well, it is not being added with anything, that is 0, so we will have it as it is. So this is the result of the hexadecimal addition. Now we are supposed to convert the result into binary. We all know each of the hexadecimal bits can be represented in a 4-bit binary. So 1 of hexadecimal will be 0001 in binary. What about D? Now D in decimal is 13 and we know decimal 13 in binary is 1101. Notice this has the place value 1. The place value of this is 4, so 1 plus 4 is 5. And with 5, if we add the place value of this one, it will be 13 because the place value of the most significant bit in here is 8. So 8 plus 4 plus 1, 13 or D in case of hexadecimal. Now what about the most significant digit 1? Since it is hexadecimal, it will also be converted into 0001. So the converted binary of 1D1 of hexadecimal is 111010001. We can always omit the most significant zeros. Let's now focus on the last question. Subtract the binary numbers. We have been given the minuend and the subtrahend. Then we are supposed to convert the result into hexadecimal. So let's try to solve it. Now our minuend is 1001101 and the subtrahend we have got as 111001. Let's perform the subtraction. 1 minus 1 will give us the difference 0. 0 minus 0 will give us the difference 0 once again. Then 1 minus 0 will give us the difference as 1. Now 1 minus 1 will give us the difference as 0. Now notice, here the minuend bit is lesser than the subtrahend bit. And as I told you earlier, from this bit, we will keep on moving towards the most significant bit until we encounter the bit which is 1. And once we encounter it, we will consider the entire group. Now notice, 100 in binary is actually 4 in decimal. And 11 of binary is actually 3 in decimal. So from 4, if we subtract 3, the difference is going to be 1, isn't it? Now we are done with the subtraction. We now need to convert the result to hexadecimal. And for that, we need to start grouping 4 bits from the least significant to the most significant bit. So let's form the first group. This is the least significant 4 bits. Now notice, we have only got one more bit. And as I told you earlier, for this, we can always consider more bits towards the left. Now we have 2 groups, don't we? Now coming to the first group, it is 0100, which is 4 in both decimal and in hexadecimal. So this will have the hexadecimal value 4. Now what about this group? 0001 is always going to be 1. So the equivalent hexadecimal of this particular result of binary is 14. So in this session, we solved 7 problems on different number systems. Alright people, that will be all for this session. I hope the journey of introduction to microprocessor was fruitful to you. From the next session, we will begin the next chapter. So I hope to see you in the next one. Thank you all for watching.